Hey everybody, so this is a problem that's kind of been given everybody a little bit of a frustration. So I wanted to work it out for you. It's question number 16, which is 3.3.26 in case yours are in some different order, but they should all be in the same order. Anyway, so this one, it gives us the mean or the average selling price, and it gives us the standard deviation. So our X bar or our mean is 350,000. And our standard deviation is 32,000. So the first thing it wants us to do is to determine the coefficient of variation. Once you know the formula, it's pretty easy. Coefficient of variation is equal to the standard deviation divided by the mean times 100. So in this case, 9.1. So that part's pretty easy. Most people have been able to figure that one out. The second is calculate the z-score for a house that sells at 312,000. Remember, the z-score is just like saying how many standard deviations is that value of x, in this case 312,000, away from the mean. We would expect it's going to be negative, right? Because our mean is 350,000 and 312,000 is below that mean. So we're going to expect a negative z-score here. I can use the Excel function standardize. And then it wants me to put x, or the amount we're testing for, 312,000. And then the mean, which is our x bar right here, and then the standard deviation. And that will return a z-score of negative 1.19. All right. The third question is to using the empirical rule, determine a range of prices that includes 95% of the homes around the mean. So we have to know something about the empirical rule, and that we can find that in the book. But in essence, the empirical rule tells us that 95% of all values are within plus or minus 2 standard deviations of the mean. You might get one that's 68%, that'd be plus or minus 1 standard deviation, or you might get one that's like 99.7%, and that would be plus or minus 3 standard deviations. If you're wondering about it, you can look up the empirical rule in the textbook, and it will break that down for you. 68%, 1 standard deviation, 95% 2, and 3 standard deviations, 99.7% of all values will fall in there. So we have to know that to make this work. So in our case, it's 95% of the homes will be plus or minus 2 standard deviations. So to find the upper bound, all we're going to do is we're going to take our mean plus 2 times the standard deviation. If it told you to find 99.7%, you would do 3 times the standard deviation, etc. And then our lower is going to equal our mean minus 2 times the standard deviation. Whoops, I did my parenthesis wrong there. And that's going to be the range. So 95% of all the homes will be priced between 414,000 and 286,000. So part 4, using Chebyshevs Theorem, or part D, I guess, determine the range of prices that includes at least 86% of the homes around the mean. This one's tougher because it doesn't give us, like Chebyshevs Theorem, kind of like the empirical rule where we broke it down to 68%, 95%, and 99.7%. With Chebyshevs Theorem, you break it down to 75%, 89%, and 94% within 2, 3, and 4 standard deviations of the mean. But here it's asking us for 86%, sorry. And so what we're going to have to do is calculate the z. Remember, z stands for like the number of standard deviations plus or minus the mean. So the formula for Chebyshevs theorem is 1 minus 1 over z squared times 100 equals the percentage, in this case 86%. So what I've had to do is do a little bit of algebra here by taking the formula and then solving it. So first we divide both sides by 100 to get 1 minus 1 over z squared equals 0.86. And then we subtract 1 from both sides. So now we have a negative 1 over z squared equals negative 0.14. Then we can divide it out. So we're left with z squared equals 1 over 0.14, which equals z squared equals 7.143. Take the square root of that, and we get z equals 2.67. This is why this class has a prerequisite of Math 140, right? You have to be able to do a little bit of algebra at times, but it may not seem obvious. So once we have a z of 2.67, what we're saying is, we're saying that 86% of the homes using Chebyshevs theorems will fall between this range of plus or minus 2.67 standard deviations from the mean. So our upper bound is going to equal our mean times 2.67 times the standard deviation. Sorry, that's not times, that's plus. So the mean plus 2.67 times the standard deviation. Then our lower bound is going to equal our mean minus 2.67 times the standard deviation. Hopefully, I took that intermediate rounding out far enough that this will work. Our upper bound 435, 440. And our lower bound is 264, 560. And it didn't like that. So probably I'm going to have to take that out a few more decimal places. So let me get my calculator and give that a try. Come on, there we go. Okay, so 1 divided by 0.14 equals 7.142857. And then the square root of that is 2.672612. So 2.672612. 672612. And so now we have our upper bound as 435,523. I'm sorry, 524. 435,524. And our lower bound as 264,476. Let's see if that works. All right, so there's maybe a good lesson in that is we have to not round off our intermediate numbers. So like right here where I figured 2.67, instead you need to carry that out several more decimal places. You saw like the big change it made in those numbers. So just remember to do the Chebyshevs theorem, the hardest part is we have to solve for the z. That gives us the number of standard deviations plus or minus the mean that our answer should be. And that's the hardest part about it. Recognize that the empirical rule is for information for data that conforms to a normal curve. And then the empirical rule is for data that we're not sure whether or not it conforms to a normal curve. That's why the Chebyshevs theorem is for data that we're not sure whether or not it conforms to a normal curve. So we have to, I guess, have more error in the equation, and that's what Chebyshevs theorem does. You can see this big range we ended up with just to feel good about 86% of the data, whereas with the empirical rule, we actually had a more narrow range, but we included 95% of all the data. So, but in real life, you often don't know if you're dealing with data that conforms to a normal curve or not. So that's where Chebyshevs theorem comes in, is we can still figure out a pretty good range. Like this, we know that 86% of the homes are going to fall between 264,476 and 435,524. That gives us a pretty good range, even if we're not sure about our data set. Anyway, I hope this was useful. And if you have any questions, don't hesitate to ask.